and other things I told you, right?
Yes,
Duct
sir.
sizing Q equal to A into V. Then again your reducer W1, W2, H1, H2 into length, all your duct fitting pieces, then your shoe neck, elbows. I think I have to start from pressures, guys. Okay, different types of pressures.
Air distributing system components.
Air distributing system components are.
ஒரு டாபிக் இருக்கு சார்.
Air distribution system components, I think it will be coming somewhere here. Components of ducting here, air distribution components. Oh, you are seeing from the syllabus link. Hello?
It's done, sir.
Yes, sir.
It's done, sir. It's
This
done.
one is
It's
done
done.
now. This one is done
Yes,
now.
sir. Add distribution is done. Add distribution system components done.
Okay.
You need to start with the types of pressure.
Yeah, this one only, no. All the distribution components, you have diffusers, grills, whatever it is, ducting, everything you told. Yesterday I have seen all the calculations, that is done. Okay, then today, pressures, types of
Types of
pressures.
pressures.
You Bagubale, what ma,
Yes,
you're
sir.
telling, you're directing me towards wrong direction, huh?
No, sir. I forgot the topic whether you have done or what.
You will confuse me, man.
Confusion is
Okay,
happiness, sir.
confuse. Okay, no problem. You can, you got everybody go in mute, I'll start the class. Okay, see, you have three types of pressure, guys. Okay, you have total pressure, you have static pressure, and you have velocity pressure. You have three types of pressure. Okay, now what is total pressure is? Total pressure is the summation of both static pressure and velocity pressure. So yeah, I should add static and velocity to get the total pressure. Okay, now, so what is the static and what is its velocity? I will tell you. See here. So a balloon is filled with air and you have tied with a knot. Okay. Now you have released the knot. So when you have tied the knot, no, what happens? The pressure will be acting perpendicular to the direction of the flow. Okay. When you open it out, the flow will be coming like this. Okay. So velocity pressure is the pressure that is acting towards the flow. Static pressure is the pressure that is acting perpendicular to the flow. Give me 1 minute. I will explain it clearly. So you have a duct here. Okay. So basically what happens, your fan, your centrifugal fan is the source of pressure. So that is total pressure is equal to static pressure plus velocity pressure. Okay. Now air is coming like this because your fan will be blowing the air like this. So this is the end of the duct. So the total pressure inside a duct, okay, the only source for creating the total pressure is your centrifugal fan. Okay, now this is the flow. If the pressure is acting perpendicular like this, okay, that is static pressure. When flow is like this, if the pressure is acting parallel to the flow, that is velocity pressure. Okay, addition of both in a system will be total pressure. But what generally happens is you will be finding total pressure, you will be finding static pressure. So Tp minus Sp will give you your Vp, velocity pressure. Generally during finding, this is how you do. Okay, this is also is manual method. In software method and all, automatically the software only will show what is velocity pressure and all, everything you will get it directly. I'm just telling you. Okay, who is the one who joined lastly? Okay, somebody was creating sound, no problem. Okay, see, so this is what you should understand between the two. So static pressure is perpendicular to the direction of flow, velocity pressure is parallel to the direction of flow. Okay, now coming back to the slide. Static pressure is measured perpendicular to the direction of flow of air. Static pressure can either be positive static or negative static. See here, if this is the fan, okay, centrifugal blower, it is sending the air like this. Now if you measure your pressure here, static pressure here, that is positive static pressure. If you measure the pressure here, that is here, okay, because for any fan to supply the air, okay, for any fan to supply the air, it should suck the air first. So this is supplier side, this is returner side, means when the returner comes to the fan, it should suck the air to the fan inlet, it should pressurize the air, then it should send. So in the suction side, it is called negative static pressure. In the discharge side, it is called positive static pressure. Okay. Now total pressure. See, the device what you use here is what you call as a YouTube manometer. Okay, manometer generally you can call it as manometer. So what happens is you are measuring it perpendicular. Okay, so that you will get static pressure. Now see here, you are measuring it parallel along with the flow. The flow is like this, your measurement is also in the same like this. This is total pressure. Now what you will do, total pressure minus static pressure, you will be getting velocity pressure. That I have told that there only. See, this is what measuring of total pressure, static pressure. When you minus it both, you will be getting velocity pressure, but in general you will not be doing like that and all. Software will show you what is what all the pressure values and all. You have to find only static pressure. Okay, you have to find only static pressure. You have to calculate. Velocity pressure will always be positive. Okay, it can never be negative. I will tell you why. See, now we have a fan here. Okay, so this is the suction side of the fan. This is the discharge side of the fan. Okay, now what happens? The centrifugal blower, you have a centrifugal blower here which is sending air now. You are measuring velocity pressure here. In case I am telling, you will be measuring like this. Okay, measuring total and minus it. So pressure is acting in the direction of the flow. Even if you measure here also, no, flow will be like this only. No? Even if you measure here also, for velocity pressure it is always be positive because it is always exerted, it is always in the direction of flow. Okay, but static pressure is not like that. This is negative static, this is positive static. Understood? Hello?
Hello.
Hello?
Hello.
Sir, it's lagging, sir.
Which one is lagging? Which one is lagging for who?
For me, sir. Abin.
Shiva, is it fine? Like it is lagging for you?
No, sir, actually, it's recording neatly.
Abu Sali? Rahul?
Clear, sir. Clear for me, sir.
I'm
Rahul?
okay, sir. I'm okay, sir.
Sippe Swami?
Okay, sir.
Okay, everybody go in mute. Abin, go out and log in
Yes.
again.
Okay, sir.
Okay. Abin, is it fine now?
It's still lagging only, sir. It's okay, sir. Okay, I'll see the recorded class. Sir.
No problem, no problem, no problem. Okay.
Okay.
So now you have got it. Okay. So up to this you have found it. So these are the three different types of pressure, guys. Okay. Nothing else is there. But what I wanted to teach you guys now only is, see, suppose you have a AC, okay, air conditioning. For air conditioning, supply duct will be there. It is always going to be distance. Okay. Then return duct will also be there. But the purpose of the fan, what you have is the air that is touching and coming from the coil. The purpose of the fan is to push the air. It is to discharge air to the rooms. Okay. So positive static of the fan will be more. Okay. Negative static will be less, because automatically from the room, once the volume is filled, then the air will be going to the return grills and the return duct, it will come back. So negative static will be there, but it will be very marginal, it will not be more. Now I will tell you one more scenario. you have a machine here, so you have a fan here, so this is your outlet. Okay, what is this scenario is, this is your ventilation scenario, exhaust, kitchen exhaust, okay, or your toilet exhaust. So what happens, you'll be having so many exhaust diffusers. Okay, now all will be connected to the exhaust duct. So during this time what happens, the negative static of the fan should be more. Once it reaches the fan, no, it is not going to push anywhere, it just needs to push outside to the atmosphere through the outlet. Okay, the outlet will be something looking like this. Through the outlet it is going to push the air like this. So positive static will be very less. For exhaust system fans, negative static will be more, positive will be less. For air conditioning supply fans, positive static will be more, negative static pressure will be very less, because it is not needed. Okay, for now just keep only in mind, during external static pressure calculation, that is the capacity of the fan, how to arrive at the capacity. By heat load, what you will get is, you will get tonnage and you will get CFM. CFM is used only one part in the selection of fan. The second part is external static pressure. You need to find these two to select your fan. Okay, so only with CFM. For non-centralized system, okay, fine, but for centralized system you need external static pressure, there is no other choice, you need to calculate it. So at that time, positive static, negative static, I will tell you clearly what about this positive static. Okay, so this, why I told this, it should give you a basic idea. Okay, positive, negative, that's all. Understood?
Sir.
So to say in very simple words, the supply fan, it should be pulling. Say suppose one guy is there, no, it should push the guy to a long distance, but pulling is very less. Okay, but for exhaust fans and all, it should be like pulling like a rope. No, it should be pull for a large distance, then pushing is very near. That's all. That is a simple logic behind this one. So that one is also done. Now